This is quiz 14. We were supposed to find the derivatives of several functions. So in the first case, f, capital F, is given as x to the fourth plus 3x squared minus 2 all to the fifth power. So in this section we knew the chain rule, we learned the chain rule, and so the derivative is the derivative of a function to the fifth power. So the derivative of any function to the fifth power from the power rule or the high school rule is 5 times whatever, x to the fourth plus 3x squared minus 2 to the fourth. But then the chain rule says you got to multiply by the derivative of what's inside. So that's going to give you 4x cubed plus 6x, and that's it. And that's the end of that problem. Now, I suppose you could multiply that 5 times these, or you could pull out a factor of 2, but there's no point in doing that. There's nothing great that happens as a result of that. So that's good enough for number 1. Make sure you don't make the mistake of taking the derivative of what's inside as you take the power rule. Okay, a lot of people, beginners, do that. 5 times, and then they take the derivative of everything. Don't ever take the derivative of everything at once. So it's the power that comes first, then you finish with that, and then the chain rule comes along and says you got to take the derivative of what's inside. Okay, number 2, our capital F of x is given as the square root of 1 minus 2x. But it's much better if you rewrite that, for the purposes of derivatives, as 1 minus 2x to the 1/2 power. Because then the derivative is given by the chain rule again. So we have the power rule, something to the 1/2. So it's going to be 1/2 times whatever to the minus 1/2. That would be 1/2 minus 1. And then the chain rule says you got to multiply by what's inside. So this is going to give you a factor of minus 2. Okay, folks, here I can see that the 2 and the 1/2 are going to cancel. So yes, I would definitely simplify that to the negative of 1 minus 2x to the minus 1/2. And that's good enough. If you want to write this as 1 over the square root of 1 minus 2x, that's perfectly okay, but there's no need. This is a perfectly good answer, although you should know that this is equal to what's up above. Okay, that's number 2. Number 3, we're given that f of x is 1 over x squared plus 1. And all we want is the derivative of that. Well, you could use the quotient rule, but I'd much rather write this as x squared plus 1 to the negative 1 if all I'm going to do is take the derivative of it, because then I'm almost done immediately. The derivative is, again, the power rule, minus 1 times x squared plus 1 to the minus 2, minus 1 minus 1, times the derivative of what's inside, and that's just going to give me a 2x. So if you want, you could write it as minus 2x over x squared plus 1, but this is a perfectly good answer. But yeah, you could write this as minus 2x over x squared plus 1 quantity squared, but there's no simplifying that can happen there. So that's number 3. And number 4 gives us y equals x e to the minus kx. And here you have to assume that k is a constant. So the derivative is going to be given by, well, what are we dealing with? We've got a product. So the derivative of a product is the first times the derivative of the second. Well, we're sophisticated by now. We can see what the derivative of the second is going to be, so we'll just do it. The derivative of e to any power is e to that power again, e to the minus kx. And here's where the chain rule comes in, because it says, well, this power is not just x. So you're going to multiply by the derivative of what's up here. What's the derivative of minus kx? X is the independent variable, so the derivative is minus k, because minus k is a constant multiplied by x. Okay, so again, first times derivative of the second. The derivative of e to any power is e to that power, and then the chain rule says you got to multiply by the derivative of that power, since it's not x, since the power is not x. First times derivative of the second plus the second, e to the minus kx, times the derivative of the first. Derivative of x is just 1. So you can leave your answer like this, or you could, if you felt like it, factor out the e to the minus kx. There's no need to do that, though. And then you're going to be left with, I would write it this way, this guy first, 1, and then minus kx times e to the minus kx. And I've got to admit that this is a bit simpler than that, but this is perfectly acceptable. This answer is perfectly acceptable on an exam. There's nothing significantly simpler about this than there is about that. Okay, and that takes care of quiz 14.